Okay, so hi everyone, Senan this side, and this video we are going to see how to solve this maximum number of points with cost. So this is a medium problem, but like it's a bit tricky. So you could get a suboptimal solution straightforwardly, but to find the optimal solution, you might have to think for a bit. So what you are given is an m cross n integer matrix points. So starting with 0 points, you want to maximize the number of points you can get from the matrix. Okay, so how do we get some points? So you must pick one cell in each row. Picking the cell at coordinates r and c will add points r and c to your score. But however, you will lose points if you pick a cell too far from the cell that you picked in the previous row. For every two adjacent rows, r and r plus 1. So pick, let's say 3, and then you pick 5. Not just you get a point of 8, but you occur a cost of 1 because this is column 2 and this is column 1. So you take the absolute of the columns. So that would be your cost to go to one step left. 3 plus 5, that will give you 8. Since you traveled one step left, it would cost you 1. So the net score for getting from 3 to 5 is 7. Similarly, from getting to 3 from 5, you shift one column to the left, so that would decrease your point 1 by 1 again, but you would get 3 points. So 3 plus 5 plus 3 is what? 6 plus 5 11, but you shifted 2 times left, so your score would be 9 along this path. So that is the out. So picking a cell, subtract absolute of c1 minus c2 from your score, and in the end return maximum number of points you can achieve. Now if you haven't solved a problem like this before, like to calculate the points, there were questions on LeetCode such as you choose a column, then you can either go one step left, just bottom, or right, and doing this approach you needed to find the maximum score. So that is, if you have solved that, this would be a piece of cake for you, but I highly suggest you to find that problem and do that one first, because if you do that, then only you would have an idea that this is a dynamic programming problem. So it's a problem, and you could even implement this with a 3D DP, but we are going for a 2D DP solution, which is an m times n solution. So I'll just show you my recursive solution, which is not of the one of the most optimal solution. It's more or less suboptimal. You would get a time limit exceeded. So yeah, before that, we just look at this. I'm just saying that if I'm on the last row, just return the whatever the point I am having. So if I'm at this row or this row or okay, basically in the last row, if I am at this column or this column or this column, the maximum point I could get from this is 3, from this is 1, from this is 1, because that is somehow my base case, right? And I just keep track of all the points. So if I'm at this point, I find the maximum point I can get from here, here, and here, and subtract the cost as well. So to get the points for this 5, row equal to 1, column equal to 1, this position, I have a cost of, I have a point 3 minus cost of 1, a point of 1 minus cost of 0, I have a point of 1 minus cost of 1. So this would, if I choose this, it would result in a 0 point. If I choose this, I would result in a plus 1 point. But if I choose this, so I get a plus 2 point, given I'm at this position. Keep this in mind. To solve this, again, you would need the values of this, this, and this, regardless of the subtract whatever point you want to. So since for this, this, and this as well, you need to have the values of this, this, and this. This is basically a dynamic problem because you have the same repeating subproblem. So let's look at the notebook and try to understand what is the optimal approach that I'm trying to go for, right? I won't be discussing this m times n square solution. That's something you would already be comfortable with. This is the same, the caller function of this. I have a DP array. Just keep this in mind that initialize this to long because it would be of great use, because I used int comma int, and that leaded to a wrong solution, not because the code was wrong, because the data type was incorrect. So logic was correct, but data type was. So let's discuss what is this optimal approach, or what I think is the optimal approach, and then we'll see how we actually code. Okay, so here we are in my notebook. So let's see, given this metric, how do we actually find the solution? Now I'll build up step by step. So what I'll do is create this array which has 3, 1, and 1 last row, and let's say this was your problem. So what would be your solution? Clearly you only have a single row, so you cannot travel beyond this, right? So what you do, so basically this is your points matrix. So what do you do? So you basically just return whatever is the max element in this one, right? So for this I would take this, keep this on the right, and let's keep this DP array for our reference. What I'll do is, since this is the last row, I'll take all the elements and place it in the DP array. If I just place the values, I would have 3, this is 1, and this is 1. Okay, so now what is the maximum value in the topmost row of this DP array? So this is basically what? 3. So for this, the answer would be 3. Fine. Now, for the case when we have this 1, 5, 1. So we are basically building from the base case to the whole question, and we are seeing how the program will see what is actually happening. So let's take this matrix, and let's say this was your points matrix in this case. So since you've seen this, what I'm saying, this, so you have this for the base case, and now I'll just build up from that. So for this one, if you take this one, if you start from this one, what is the maximum point you can get, right? So I'll just draw this. What is the maximum point you can get from here? So first of all, since you're starting from here, you can take this as your points, and you'll just say 1 plus what? Now either you can take this, or you can take this and have a cost of 1, or you can take this and have a cost of 2. So basically what this matrix is choosing as its maximum value is what? 1, which is the points of this row and column, plus max of what? This 3. So let's write it like this: 3 plus cost is 0. So this is the value of the DP array, and this is the cost associated with this. Next, what you would have is 1, which is this, but it has a cost of 1 because you're basically going one step to the left, right? So you would have a cost of 1. So that means you would have subtract, because this is the cost here and this is the value from the node onwards. Now the next thing what I would do is look at this one. So what this would be basically 1, the value itself, minus the cost 2. Why 2? Because you're traveling 2 steps to the left, so that would give you a cost of 2. This is your final value for this matrix, this location in the matrix. So what is this? Basically this is 0, this is -1, and this is 3. So clearly the max of this is 1 plus 3 is 4. So you can attain a maximum value of 4 at this position. Clear? I hope that is. Let's do it for the next index, this index. Now clearly you would have a cost of some points of 5 plus what? Either 3 with a cost of 1. So I'll take that as max of 3 with a cost of 1. So 3 minus 1, 1 at a cost of 0, and 1 at a cost of 1. Hope this is clear. So what do you get? So you get this is 2, this is 1, this is 0. So max of this is basically 2, which gives you a net value of 5 plus 2, which is equal to 7. So I write 7 at this position. Okay, now finally what we do is check for this last element. So what I would get is 1, which is the value of this node, the points. So 1 plus what? Max of what? Max of 3 minus 2. 3 minus 2, because cost of going 2 steps towards the left is 2, or what you get is 1, value at stored here, minus the cost, and similarly 1 minus cost. Basically for choosing this value you occur a cost of 2, for choosing this value you have to minus cost of 1, for choosing this value you have a cost of 0. So what this will give you is basically 1, 0 and 1. So you choose whatever the maximum is to you, and write the value. Max is 1, so this would be okay. So now let's understand what is happening in this case. So basically after this second iteration, I know that the maximum I can attain starting from this location is 4. And how do I get that? So I take this value and just take this value. If I go towards the left, I would occur a cost of 1, the point of 1, so that won't give me more than 4. Similarly, this won't also give you a better solution. Now starting from this, what is the maximum value attained is 5 plus 3 minus 1, because the cost, that is the value 7. Now starting at this position, what is the maximum you can attain is basically 2. Either you take this or you take this. Both of them is basically 2, and that is the maximum you can get starting from this location. And now given this matrix, what do you think is the maximum value you can achieve, maximum points you can achieve? So either you start from here and get the points, or here, or get the points, or here and get the points and find what is the maximum you can get among the top row. So among this I can have a maximum value of 7, so 7 would be the answer that I need. So given this as your points matrix, 7 is your answer. Now let's build up one more level. So what is this? This is 1, this is 2, and this is... Now I'll not be doing the max thing that I did. I just straightforward write the solution. So what I can attain is either starting from this, for this location I have a point of 1 which I can take, or I can take a point of 4. So 1 plus 4 would be 5. Okay, the other case would be 1 plus 7 minus 1 because it would take a cost of 2. 1 plus 7 is what? 8. It is 1. The value is again 7. And in the last case I can take a value of 1 and occur a cost of 2 and add this value 2, so I would still stay at 1. So the maximum that I was able to get in this case is basically the value, this 1 and this 7, and the cost is minus 1. The final value at this location is 7. Now let's look at this case. I can have points 2, I know that for sure, but how much can I get from the remaining nodes? So clearly 2, or after that you can just have 7, right? 2, and just take the element below because that is the maximum in this array, and you won't occur any cost because you're just going down. So that would give you a cost of what? This would give you a cost of 9, the max value. Similarly, if you see this and compare with this, if you take this 7, then and only then you will get the maximum value. 3 plus 5, or basically 3 plus 7 is 10, but since I moved one step towards the left like this, the cost would be 1. So the net I would attain from this node is also 9. Now what is the answer for this whole matrix? The answer for this is this, the max in this. So what is the max in this? It's either this or this. So basically you have two paths through which you can get the maximum points, which is 9. So what you can do is either this or you can go directly this. So you have two solutions. Now let's say if someone asks you what to do if I have one more layer of numbers, let's say 3 to 1. So how do we do that? Again, we'll just extend this, and what I would do is I'll compare the elements. So if I get 3 and 7, that would give me 10. If I take 3 and 9, it would give me 12 with a cost of 1. If I get this and this, again be 12 minus 2, which is the cost, so that would be 11. So the maximum value I can attain is what? Is 12, right? From here to here to here to 3 plus 2, 5 plus 5 is 10, plus 5 is 13, and you shifted one step left, one step right, and one step left. So this should be what? 5, 10, 13. 13 minus, so this would not be 12 but would be 11, right? So if I just immediately go from this to this, that is 10, this to this, that is 12, plus 9 is 12, but cost of 1, so 11. And if I go from this to this, it's again 12, but cost of 2, that is 10. So the maximum value is 11. Now next what I can do is I can check for 2, and what that would give me is 2 plus 9 is 11, and 11 would be the max, just 11. And if I take 1, either way, the maximum value could be 10 only by taking this. Okay, so similarly you can build up as big as you want. You can add more columns as well. The logic would be same, and there are two things that you need to observe. One, to calculate this row we just needed this previous row. We did not need the whole matrix, right? So to do this I can just have a DP array like this and another DP array like this, storing the previous and the current value. So that is the point. And now let's see what is the time and space complex. So in this case you are basically seeing, let's say this is m, this is n, so you are going for m times n, right? And then checking for the maximum element in the next row. So the time complete is m times n, which should not be the order of this. We have to improve that. We can do is, rather than going here and just checking all the elements, we'll just store these elements and keep track of what is the maximum we could attain. So let's look at this two cases, right? Okay, so let's look at this case that how do we remove this one more n. So what I'll do is I'll keep two arrays, separate arrays, left and right, keep track of this. So what would be is, let's take this last two, 4 7 2 3 1 1, and we need to calculate the value of basically this node. So 4 is not here, let's say 3 1 1. So now what I would do is basically keep track of the left one and this left array would be defined as follows. Either I take the maximum value. So if j is basically, let's say j is equal to 1, 0, 1 and 2. If j is 0, what I would do is take the value at dp array. So that is 3 itself. Now I look for this position. So either what I do, I take this value, or I take this value, or decrease this value by 1 and place. So whichever is the, if I take 3 and subtract 1, because I'm going one step towards the left, that would occur a cost of 1. So either this could be 2 or this could be 1 as it is. So whichever is the max, I take that. So max is 2. I'll place the value 2 here. Now for this node, what I can do is I can take this value and subtract 1 from it. So 2 minus 1 or 1. So like take it like this. I take this value and place it here, and the cost would be 1, 2 minus 1 and 1. I take the max of this, so that would give me a value of 1. Now similarly I would keep track of this right array as well. Now what I would do is, since I'm starting from the last column, so I would place the value exactly whatever is in the dp array. I'll just copy it here. In the next case, for this node, what I can do is I can take this value of dp, or I can take this value and subtract 1. So in this position I'll put max of 1 minus 1, or the dp value, which is 1. The max of this is 1. So I'll place 1 at this. Now for this location, what I would do is I would take this node, this value, subtract 1 from it and place it here, or take the max value of, or take this value, whichever is the max. So take this, subtract 1, or the max, this value. So take the max of both. So basically this would be 3 itself. Now if you observe, what we have to do is see the value here, right? Now what we have to do is keep this points array somewhere close to. So I'll just remove this and drag this few positions so that it is easier for us to understand. Now what I do is I need to fill these values, right? I need to fill these values. How do I fill that? I take the maximum element of this and add with this and place it here. So the maximum element of 3 and 3 is 3 plus 1, so I keep value 4 here. I take the maximum value of this and add to this and I place here. So what is this? 5, and max of this is 2, so 7 here. And I take this and the maximum value present here and sum them, so you get a value of. Now if you observe, using these two arrays, we were basically able to get this in linear time. We did not have to search last row for each and every node. We just pre-computed left and right for each node, and that allowed us to find the values of 4, 7 and 2. So that is the whole logic behind this. Hope you get this. Now your task is to do this for one more level, and now we'll see the code exactly of how I actually implemented logic. So we are back at my computer screen, and now first of all, basically we need to get m and n, right, the rows. And now I define two vectors, the previous and the current, right, to keep track. Basically if you see, I'll just comment this recursive solution out of, and what I do is, okay, so I get the rows and columns. I define two vectors, current and previous, to track of the values of the dp, right? Now what I do is, for the base case, that is when we are at the, we only have a single row, so that means whatever the points is my solution, right? We did that in our example. Now what I do is I keep a left vector and a right vector here, and now what I do is, first of all, from the base I am trying to build up, so I am first of all calculating the left value, then I am calculating the right value, just as I explained you, right? Now what I do is, for this value, for the current row, I take the previous value, okay, or basically I initialize the row previous to this one as points of ij, right, plus max of right of j or left of, and then I reassign current to previous. What I think is, we don't actually require basically two previous and current. This would be, let me just check this out if I can do this without the previous. Okay, so as you can see, we don't actually require the previous row, so just take this current row and this track as dp array. And now what you do is, first of all, calculate left, right, and based on left and right, what you can do is update your current value of j, which is points of I and j, plus max of right of j or left of. And in the end, what you do is find whatever the maximum element is, right? That is what you would do. So if you see, we are traveling for n times here, n times here, and n times here, and this for loop is going for about m times, and since we are considering this, the for loop is going for m times, so the time complex in this case would be exactly m times n. and the space complexity is 3 times n, big of 3 times n. You have a current vector, you have a right and you have a left. So that is something that you can do. One more thing you can do is, just rather than having different left and right, you can do it on the same vector, right? You don't, in the end, you don't have to do the max operation, you just assign that value. But let us leave this at what it is, because it's easier to understand what I'm trying to do. Because at any point of time, either you take a value towards the left or from towards the right, whichever is the maximum, you take that. So that is the video all about. This time and space complexity, as I discussed, is that time is m times n and space is big of n, and returning this would take a big of n time again, because you're searching the whole array. So yep, that is the whole video all about. Hope you understood it. Hope I was able to make you understand with the help of the notebook or the dry run of the code. And yep, thanks for watching, and I'll see you in the next